Welcome to today's webinar, Pervasive Application Performance and Security Monitoring featuring Big Switch Networks and our partner ExtraHop. My name is Angelique Medina. I'm Senior Product Marketing Manager here at Big Switch, and I'll be your host for today's webinar. ExtraHop is a leading real-time IT analytics provider, and Big Switch Networks offers a highly complementary network packet broker fabric that delivers pervasive and granular network visibility to their analytics platform. Before we dive into our topic today, we want to invite your participation during the webcast. As we go through the presentation, please feel free to ask questions during the Q&A that we will answer at the end of the session today. So on the right-hand side of the webinar dashboard, you can pose your questions, and at the end of the session today, we will answer them. And if we're not able to get to them due to time, we will directly respond to you after the webcast. We also have handouts for today's session. You can access them on the right-hand side again. There's also some additional information on Big Switch Labs, which you can go to at bigswitch.com and get additional information there. So we have a joint session today. Joining us from ExtraHop is Tyson Supasitit, Product Marketing Manager, and Colin Walker, Technical Marketing Engineering Manager. On the Big Switch side, we have Bala Ramachandran, Director of Product Management, and Ted Alhurani, Technical Marketing Engineer. We have a full agenda for today's webinar, so let's get started. We're going to start with an overview of Big Monitoring Fabric. And we're going to specifically touch on how it differs from traditional network packet brokers, where it deploys, and how it benefits Net and SecOps teams as they deploy and manage their monitoring systems. Next, we'll have an overview of the ExtraHop analytics platform. Then we have two demonstrations, one from Big Switch, the other from ExtraHop. And finally, we'll have a Q&A session at the end to answer questions that have been submitted during the presentations. So with that, I will turn it over to Bala.
Thank you, Angelique. So let's start our discussion today by looking at some of the modern-day challenges involved in monitoring. We are seeing tremendous growth in traffic in data centers, and the bandwidth needs are getting larger and larger. So we are evolving from 1 gig, 10 gig to now 10 gig, 40 gig, 100 gig. The majority of this increase, estimated to be around 70%, is driven by intra-data center traffic. What I mean by that is traffic between servers in the data center, also known as the east-west traffic. Monitoring this increasingly dynamic traffic is a daunting task for enterprise IT. Now, cybersecurity is another huge driver for monitoring in organizations. Cyber attacks are increasing in volume as well as complexity. So what this means is that there's a compelling need for monitoring traffic across the data center rather than at specific points in the infrastructure. Now, traffic in the data center is typically monitored with tools for forensic analytics, threat protection, application, and network performance monitoring. And typically, network packet brokers, or NPBs as they're called, are deployed to aggregate, filter, replicate, or load balance traffic going to the tools. But traditional NPBs are complex, they're expensive, they're proprietary boxes that restrict the scale of monitoring because of the prohibitive costs. They're operationally challenging because of box-by-box management, and they also cause tool silos as more of these boxes are added as discrete units as monitoring needs grow. So people just cannot even think of monitoring everywhere in the data center with these traditional NPB solutions. Clearly, a scalable approach is needed. This requires a next-generation packet broker with a next-generation architecture that allows the monitoring infrastructure to scale easily along with the production network, offer ease of operations and management, and is low cost, so it can be easily and affordably deployed, making pervasive monitoring a reality. Big Monitoring Fabric is that next-generation packet broker that offers SDN-driven scalable monitoring, automation, and ease of management. Now, let's look at how Big Monitoring Fabric, or Big Mon in short, offers these next-gen packet broker capabilities to enable pervasive monitoring in data centers. Now, as you can see, the Big Mon is a fabric of 110, 40, 100 gig switches managed by a pair of controllers running SDN software. Now, these switches themselves are open networking switches, and we partner with vendors like Dell and Acton, who provide this hardware, and they run Big Switch's SwitchLite operating system. Now, the key thing is the fabric is abstracted as a single logical switch to the controller. So the fabric, you can start out small from one switch, and then the fabric can be scaled out in a very automated fashion by adding more switches. And still, as the switches grow, as the fabric grows, it's still viewed as one logical switch from the controller, and the controller acts as the single pane of glass for control and operations. So what this means is that you no longer have tool silos with this approach of unified management. And with this automated and extensible architecture, we have pioneered use cases such as tap every rack, and you could basically tap and span traffic from every rack in the data center to send a copy of the production traffic to the monitoring fabric for any workload running on physical servers or as VMs or containers. So tools themselves can be aggregated in a centralized tool form, and with functionalities that can be configured from the Big Mon controller, such as the packet filtering, aggregation, load balancing, packet replication, and so on. NetOps and SecOps teams can ensure that the right traffic is sent to the right monitoring tool. So this essentially ensures optimal and intelligent use of tools, while simultaneously expanding the scope of monitoring. Now, a very important component of this solution is the Big Mon service node. Now, it is a DPDK-based x86 appliance, again managed by the same controller. Now, this service node provides advanced functions like regex matching, deduplication, slicing, packet slicing, header stripping, net flow, and so on. All features which can again enable efficiency of the tools by sending them the most important and interesting traffic for monitoring. Now, DMZ is an important location for deploying security tools. Now, we have a Big Mon inline security solution, again managed from the same controller, where you can achieve dynamic chaining of security tools and steer traffic through the tools as desired based on user configured policies. Next, with Big Mon, you can also do centralized monitoring of remote data centers, POPs, branches, across the L3 WAN. Tools can be located in a single tool form in the centralized data center, or they can be in the local branch office. And finally, Big Mon is bringing in capabilities to monitor public cloud workloads and deliver them to either cloud-based or on-prem monitoring tools. So overall, I mean, if I were to summarize, Big Mon enables pervasive monitoring capabilities for different types of workloads hosted at various locations, be it the data center, the remote branch offices, or the public cloud. Now, let's talk a bit about ExtraHop and Big Monitoring Fabric, how they the joint solutions are, and how ExtraHop and Big Switch have collaborated on these joint solutions to bring the combined benefits of Big Mon's pervasive monitoring capabilities with the intelligent analytics platform from ExtraHop. Now, with a data center out-of-band monitoring solution, customers get a very easy to deploy scale-out solution by leveraging the benefits of SDN architecture, with policies defined by the user from a single pane of glass controller, and by leveraging advanced packet functions provided by the service node like packet deduplication, as I talked about. Right traffic can be directed to the ExtraHop device, thus optimizing the utilization of the tool, allowing for more of the data center traffic to be monitored as well. Now, with remote monitoring, the traffic can be sent to the ExtraHop device in the data center or selectively sent to a local device in the branch office itself. Again, all managed from the same big mon controller. And the third use case we have with ExtraHop and Big Mon is monitoring of the traffic in the public cloud with the Big Mon and ExtraHop instance deployed in the cloud. We will take a closer look at this solution next, but in summary, there are these three deployment scenarios or use cases where ExtraHop and Big Mon can be deployed jointly. Now, what we have here in this slide is an illustration of how the monitoring of public cloud workloads can be achieved with Big Mon and ExtraHop instances deployed in the AWS cloud. Now, you have the production VPCs, which host the app and web instances. A Big Switch agent sends a copy of the traffic from these instances to the virtual switch, which is managed by an instance of the Big Mon controller. A service node, just like how you have in the on-prem case, you can have a service node, and we can provide advanced functions like deduplication. Now, this out-of-band traffic from the production workloads can now be delivered to an ExtraHop instance deployed in the cloud based on policies. So traffic delivered to this instance can be steered by policies to ensure that the optimal traffic is delivered to the tool, and all the benefits that you see with the on-prem solution can be made available with this public cloud solution. Now, before we move on to learn about the great benefits offered by the ExtraHop platform, I wanted to summarize the benefits offered by this joint solution. First of all, it's an extremely intuitive to deploy and provision the big monitoring fabric with ExtraHop platform. Big Mon operations are simplified and automated from a single pane of glass, SDN controllers. Now, with the ability to seamlessly scale out the monitoring infrastructure elastically without any operational overhead, you can start small and monitor all the way up to thousands of links in the data center and across multiple locations, and pervasive monitoring becomes a reality for our customers. And it enables visibility and a very broad monitoring scope. Finally, with the low CapEx investment and aforementioned operational benefits, the solution is extremely compelling from a TCO point of view. So with that, I'd like to hand it over back to you, Anjali.
Thanks, Bala. It was a great overview. So now we're going to get into the ExtraHop Analytics platform, which is what we've shown our platform feeding into in the previous slides. So with that, I'm going to turn it over to Tyson Subrasatid, Product Marketing Manager at ExtraHop. Tyson?
Yeah, thanks, Angelique. Thanks, Bala. So Big Switch is a great partner. Companies that are considering Big Switch are they make it's a great pairing with ExtraHop. They're both forward-thinking, kind of API software defined, in that world. If you can advance to the next slide, please. Can you advance to the next slide, please? Oh, that's weird. I'm not seeing it. Okay, it was just laggy. So what ExtraHop's doing is really taking a different approach to monitoring your network traffic. As Angelique said, ExtraHop is an IT analytics company. We're just using network traffic as a data source. So we're taking the raw traffic from the big monitoring fabric, and we're transforming those unstructured packets into structured wire data in real time through our real-time stream processor, and extracting the valuable L2 through L7 metrics. And from there, with that data, we do all kinds of cool stuff with it. We have a machine learning service in the cloud to detect anomalies. We have a NoSQL transaction and query, search and query appliance. And then if you want to do the traditional forensic packet capture, you can do that as well. And what do you do with this? Customers, basically, they, network and IT teams understand the inherent value of wire data. They understand that if you really want to get to the root cause of an issue, often you're going to rely on a PCAP and somebody with a Wireshark expertise to really find out the root cause. So people understand the value of wire data, but it's useful for all types of issues, from monitoring customer experience to detecting security threats to troubleshooting application and network performance issues. Next slide, please. Thanks. So I wanted to talk a little bit about TCP State Reassembly. This is kind of a esoteric and geeky thing, but it's really kind of it's the secret sauce that ExtraHop brings to the table. We talked about the real-time stream processor, but what does that mean? What does it do? So as the unstructured packets come in, they're out of order, they're chaotic in a production environment. We have very, very good heritage, technical heritage in this type of full stream reassembly. So what we're doing is we're reconstructing the client TCP state and the server TCP state for every client and server interaction on the network, and that scales up to 40 gigabits per second. So we're taking those raw packets, we're reassembling the sessions, flows, and transactions, and then we're extracting those L2 through L7 metrics. If you want to read more, you can download the overview white paper that's available in the resources section of the webinar. But basically, this is our secret sauce, and I encourage you, if you're interested in any next generation network analytics or monitoring solution, compare what they're doing, whether they're doing this in real time or whether they're doing this ad hoc. The real time nature is really important. By doing this TCP state reassembly up front and doing the analytics first, you can know about problems before you get the phone call. So with traditional solutions, you hear something's broken, or you find out there's a security incident, and then you go to your tool, and then you do a painfully slow query to try to find the right packets. Hopefully they're there, and then you do your troubleshooting from there. But ExtraHop's really turned that on its head. Next slide, please. So what this allows you to do is you can discover every digital interaction occurring in your environment. The ExtraHop appliance automatically discovers and classifies every single device. So if we see it operating as a web server, we classify it as a web server. If we see it operating as a storage server, we classify it accordingly. We allow you to observe every single transaction, not only in real time, but going back months. So on our box, we guarantee 30 days of look back, but you can utilize your own NAS infrastructure to store metrics as far back as you want. So you could compare, this week to the same week like 6 months ago. And then finally, this enables actionable analytics. It's a very intuitive, streamlined workflow. If you have something like an IP address or a username, just type that into the search, and you're really, really narrowed down on the actionable stuff. And Colins got some great demos that just show this off. Next slide. So as I mentioned, there's the Discover appliance that's doing the real-time stream processing, and that's kind of our core appliance. That's the linchpin, extracting those layer 2 through 7 metrics in real time. But we have some optional appliances as well that enable neat capabilities. So the Explore appliance enables you to do NoSQL transaction search and query. So you can take all of those transaction records and you can kind of slice and dice in them and do some multi-dimensional analysis. And then our Trace appliance is for those organizations for security or compliance reasons. They really need the actual packets, the packets of record, and that does continuous packet capture. And then finally, our Command appliance aggregates all of these and gives you a centralized view of everything. Next slide, please. So finally, the final thing I wanted to talk about is our open data stream capability. So this wire data is incredibly valuable stream and source of information, but we're not locking it into our own proprietary data store and it only stays there. We believe that it's your data. You ought to be able to do with it what you want. So you can stream events and metrics in real time to other platforms. Maybe you have a Elastic business intelligence solution that's built on Elastic or MongoDB, or you can send it to a next generation firewall or a network access control device. Say if ExtraHop detects a ransomware infection, you can quarantine the infected clients and then also block the malicious IPs, for example. And with that, I think we should just, I wanted to ask Angelique, are there any questions from the audience?
There are, Tyson. We've actually had quite a few come in. We have a few minutes. We can cover a couple of them, and then for the remainder of them, we can see if we can get to them at the end. So one of the questions that we had was about encrypted traffic and specifically how your platform handles encrypted traffic.
Yeah, that's a question that we get very often. ExtraHop, if we do need your SSL keys, you load them onto our appliance, and then we decrypt in real time. So, you know, with a hardware assist at the highest scale, we can do 40 gigabits per second of bulk decryption.
Great. And so the other question that we'll get to now is about the granularity of the metrics.
Maybe Colin, do you want to take it?
Yeah, sure. So I'll demo some of this. So hi, I'm Colin Walker. I'm going to be demoing some stuff. I'm the token geek in the room here for ExtraHop. But the data gets pretty shockingly granular, and I'll get into this in a minute here, but we're able to actually go all the way in one very fluid motion from high-level insights. So we're kind of pushing towards this insight-first methodology, which is a very new thing in the industry, and I'll talk about that more when I get my time in the sun here. But we want to be able to do things where we're giving you the information you need about a transaction at the very beginning and making it as easy to gain information and insight from that as possible. But then if you want to drill down into the details of, okay, great, I know I needed to know that I was getting some database errors, for example. I know that now, but I want to know what errors, from which server, at what time, what was the user that requested them, what was the query they sent, how many times have I seen that query, and on, all the way down to, up to and including, great, now give me the packets for that specific query when it happened. We can do all of that. So the granularity is really, really fine.
Great. And again, we do have some additional questions for you, and we will save those towards the end after our demos. So with that, let's go ahead and move on to our demos. We have two of them today. Again, Colin, you introduced yourself again. You're the technical marketing engineer at ExtraHop, and of course, Ted Alhurani is our TME here on our side. We're going to start with Ted, and he's going to get into the big monitoring fabric and show us the interface, and then after Ted, we'll move into Colin's demo. So take it away, Ted.
Thank you, Angelique. So in this first demo, we will show you how big monitoring fabric will efficiently bring out-of-band monitoring traffic from really every corner of your production environment.
Before we jump into the actual demo, let's go over the demo setup. For the demo, we have 4 switches forming our out-of-band monitoring fabric. 2 switches are configured with filter ports. This is where our mirrored production traffic is received, and we call these switches the filter switches. 1 switch is configured with delivery ports, to which we attach the ExtraHop appliance. We call this switch the delivery switch. We connect our filter and delivery switches through a core switch to form a leaf spine topology. To the core switch, we connect the big monitoring fabric service node appliance for advanced packet services like dedupe and regular expression pattern matching. We manage the entire fabric, including the service node, from the big mon controller. With this setup in place, we can receive mirrored traffic on the filter ports and with user-defined policies, filter, apply advanced packet functions, and then deliver the traffic we care about to the tools. For this demo, we have three sources of out-of-band traffic. First, we achieve full data center network visibility with physical tap and span and with mirrored traffic from virtual switches. We then have out-of-band traffic from the DMZ via Big Mon's inline span sessions. And third, we feed the monitoring fabric with traffic carried inside a GRE tunnel from remote Big Monitoring Fabric filter switches. Finally, we attach to our delivery switch an ExtraHop appliance. On the top page of the BigMon controller, we get a summary of the entire fabric. First, the current state and health of the BigMon controller itself. Then, the inventory of switches in the fabric, the number of switches, 8 switches, how many are in out-of-band mode, 5 in this case, the number of switches in inline mode, and the number of service nodes. We also get the number of the interfaces in the entire fabric. For each of the switches, we get the TCAM utilization, as well as each interface's bandwidth utilization and state. Now let's head over to BigMon out-of-band to configure a policy. We'll call our policy ExtraHop, and we'll leave it in the forward action mode. We next need to configure rules for this policy. These rules will be used to match traffic. You can match on ether type, IP protocol, source and destination of the traffic, and a number of other parameters that you can choose from. However, for this demo, we're interested in delivering all of the traffic to the ExtraHop appliance, so we will say match all traffic. Next, we have to choose our filter interfaces. First, we choose the interfaces in our data center. The VMware filter interface that will get our traffic from the virtual distributed switch, and a second filter interface that is connected to a span port in our data center. And next, we choose a filter interface that is connected to our inline span session to get traffic from the DMZ. And finally, we choose the remote location filter interface to obtain traffic from our remote Big Monitoring Fabric switch. We next have to choose our delivery interface. And for this demo, we have already configured an ExtraHop delivery interface. And before finishing, we need to insert a managed service to deduplicate the traffic. We choose the sequence number of 1, and we only have one service, and we save and finish. Before we head over to ExtraHop, let's take a look at the interface traffic. As you can see, there's traffic coming on all of our filter interfaces and on the delivery interface. With this policy in place, we are able to get traffic from 3 different sources covering our entire production network. We are then deduplicating the traffic to deliver unique copies of each packet to the ExtraHop appliance. We are now ready to go to the ExtraHop appliance to verify that this traffic is being received. And as you can see, we have traffic now on the ExtraHop appliance. We can see the network throughput, the layer 2 packets and their sizes, as well as a large number of other metrics that the ExtraHop appliance provides to the user. For instance, the bytes by layer 7 protocol, and most importantly, the TCP round trip time, as well as packet count by protocol.
So that's it for the demo. Back to you, Angelique.
Thank you, Ted. There was a question regarding the ability to filter traffic. So does the filtering of traffic require a service node, as you showed with the deduplication?
So Angelique, there are a lot of things you could do on the switches themselves. First, you can of course match on layer 2 to up to layer 4 headers, and you can go even up to 128 bytes into the packet. And so this is what you can do on the switch itself. And of course, beyond that, if you need to do more sophisticated matching and filtering, you can use our service node that would really give you a full regular expression matcher, and that's really unique. And you can also get traffic up to 160 gigabits per second with the service node.
Great. Okay, so now we are going to hand it over to Colin for your demo. Colin, go ahead and take it away.
Sweet. Thanks very much, folks. So we've talked a bunch about what ExtraHop does conceptually, and I want to touch on a couple of those things, but try and make them a little bit more real as we go through and show them. So Tyson did a great job talking about how we collect raw packet data, basically, the things that get spewed out by endpoints, clients, servers, et cetera, and how we align that stuff into what we're referencing as structured wire data, right? And really the secret there is that we are going through and in real time analyzing the traffic that exists on your network anyway, and we're turning that into usable, rapidly accessible, and queryable metrics. So this is kind of the end result of that. Once we get those metrics and we're gleaning those things off of the wire in real time, we are then able to do many things with them. Kind of the default base thing we do is create custom dashboards. So here you have a visualization that shows some very basic information that as soon as you plug the ExtraHop box in, you walk away. Like Tyson said, it does auto discovery, which means we're analyzing each protocol. We understand 7-ish protocols out of the box. It's not just doing, port-based, hey, I see port 80 traffic, therefore it must be HTTP. It's doing things like actually doing reassembly and investigating the packets and saying, oh, I see the appropriate headers and the appropriate configuration of data, and you're off to the races. So immediately you start seeing, okay, I can break out my traffic by the particular protocol that I'm seeing. I can see if there are any behaviors in there that I'm concerned about. I start getting bubbled up high-level information about how many responses am I seeing, how many errors, are there request timeouts happening or retransmits, or all of that kind of stuff. That's super table stakes out of the box. You've done zero customization. You plug the box in. Congratulations, you have this data. And again, all of this is real time. All of it's happening automatically, right? There's no configuration required. The thing that I like to poke at a little bit is, okay, great, this is nice. There's some flow metrics happening here, but this doesn't talk much about what you're actually getting out of this. So when we say that we understand the actual transactions from both the client and server perspective, and that we're digging into these things on an L7 level, not just a here's your network information level, I like to kind of poke a little deeper on that. So here we're looking at some information about database stuff, right? So in this demo environment, we have some database servers running. We have some clients that have scripts on them that are running database queries and traffic and simulating users, and we just have an ExtraHop sitting there seeing those transactions in between. No installation, no agents, no any of that kind of stuff. It just sees it. So again, we can see processing time, server errors. We can see all of the high-level metrics you imagine to see. But where it starts getting really interesting to me, at least because I should mention I'm a reformed software engineer, so I'm very much application-focused usually. You can start seeing things like, okay, I can see individual processing times by server or by client or whatever you want to bubble up. But you can also start seeing things like, oh, I can see the processing time per method, which means in real time, we're digging into each SQL transaction that's flying across the wire from a client to a server. So, Bob logs into a web app somewhere, and that has to go make an auth request to a DB somewhere, and so on and so forth. We see that, or a e-commerce app or whatever. We see that, and we can start tracking metrics about that and say, okay, how long did it take for that database server to respond? And we can toggle these things based on really anything you want. This is all very customizable, very configurable for your environment, and it's not just one protocol. It's anything that transacts on the wire. So if it has an IP address, it can't hide. We can see it. We can get information about it. We can track it in real time. We can give you metrics, and you can start pivoting and saying, all right, I want to know how long it took to process, or were there any errors? And if so, what type of errors were they, and where did they come from, and where did they go to? And I get excited. Forgive me. So let's walk through perhaps a more full real-world scenario. Very top of mind for everybody is the idea of security, right? So what I'm going to do here is I'm going to use our time picker to change the interval we're looking at. I want to look at the last 24 hours of traffic. As Tyson was saying, we have looked back far further than that. You can look at traffic in the last 30 minutes, 30 days, et cetera, et cetera. So I want to look at the last day of traffic, and I'm now using this custom dashboard. This is a thing that ExtraHop developed. My team, actually, the TME team developed, and this is looking at advanced persistent visibility. So the idea of security in an age where we're no longer just looking for how many brute force attempts were there, although we want to see that as well. We want to see behavioral issues. We heard earlier that the vast majority, almost 70% of traffic these days is east-west traffic, right? Traffic between servers. So it's not enough to say, yep, I have a good IPS-IDS solution, I'm preventing things at the edge, and I will never be infiltrated. Well, that's just ridiculous, because that's not how it works anymore, especially with things like ransomware and those sorts of things, where the attack vectors are real usable situations where you can't stop users from downloading Word docs. So what if somebody does start to get a toehold on a system somewhere? There are some behavioral things that we can then look for and say, all right, are we seeing those behaviors? In this case, we're looking for things like ICMP pings, right? Is there a large volume of pings that exist from a system? And if so, we can look at that over the last, again, any time period. What about, so that's already potentially concerning because we shouldn't see a whole lot of ICMP, but by itself isn't an issue that we should track down. But what if we start combining and correlating multiple data points? Because this is really where ExtraHop shines, not just a single data point or single alert based on some signature. It's that you're able to actually start correlating multiple pieces of data and getting a full picture of user behavior, or in this case, perhaps script behavior. So we see that we have a certain system have a high volume of pings, and we see that same system doing some TCP port scanning. So we see them sending a lot of TCP SYN requests, which is indicative of something like, you know, somebody's trying to see what ports you have available in your system. Okay, so that's already concerning, but we want to dig deeper. We see, all right, we also see a large number of database brute force login attempts from the exact same server. So now we've got a picture that's being created in our mind here where we have somebody that's doing some pings to see what servers might be available. They're then reaching out to those servers to see what ports are open. They're then contacting the servers that responded as if they were databases and trying to log in. And then finally, kind of the scariest part is we actually see the SQL requests, and we actually see an FTP data transaction, meaning somebody was shipping data off a network somewhere. Okay, so that's well and good, but somebody asked earlier about granularity of metrics, right? So this is very high level. These are our dashboarding systems. It's the, hey, you should take a look at things, or at least here's what's happening. But I want to see more, so I want to actually dig in and see the actual transactions that are being reported when it says that there are database login errors. So what I've done now is I've transitioned over, same time period, I'm looking for any database transaction that has an error that came from that node bad client, and I can very, very quickly see, all right, well, look, here's a list of all of the errors that I've had individually, and I can see that they're going through and attempting multiple generic usernames trying to log in. I can see anything that I want to about that transaction, when it happened, which client it was, which server it was, the entire actual query if I want it. And again, this is just a subset of the available fields. There's a huge amount of data I could show about any of these transactions. Already, that's pretty interesting, but let's go back to the actual dashboard and say, all right, so now I know that they were attempting to log into my database. What were they doing once they were accessed to database? Well, again, the full L7 data is available, so we're able to see here are the actual queries they were running. Again, same suspicious IP address into my database server. I get methods, I get statements, I get the actual processing time. I get to see how much data they got back. I can actually see if they were successful in getting data queried out of the database and what that data was. Again, pretty useful stuff. Again, toggling back to the actual dashboard. So now I want to see kind of the one final thing, which is, all right, I said that I already saw a user login, or I saw them doing scans, I saw them running database queries, and then I saw an FTP transaction. Well, here's that FTP transaction. Again, same user, same time period, same IP address, and I can see here's what they actually tried to send and where they sent it to. So I have a full picture of what has been happening and the actual behavioral patterns of things that I can see in real time. And I can see it in real time. I can, if I suspect that something may have happened, I can forensically look back in time and see if it did occur, and I can prove all of those things. What's really interesting is it's not just that we're able to go this deep, we can actually go deeper than that. So one of the things that I always like showing off, because I think it's a really, really useful feature that is easy to look over, all of that is relatively designed, right? We built a demo, we built a thing in there that says, okay, put a link here that goes to a certain query, et cetera, et cetera. One of my favorite taglines the company has ever put out is go play in traffic. And I love it, it's phenomenal because it's the truth. So one of my favorite demos, because I'm a giant nerd, I like this stuff, you may have noticed, is, okay, we have this search box. This search box is an amazingly powerful, very simple part of the platform because it's a global search. So it searches through every metric that exists on the system, every device that we've seen, all of the applications that we've stored, as well as all of the actual transactions. So something as simple as, hey, I want to see if people are, pick a thing, accessing Reddit. Great. So I type Reddit into the search box, I hit enter, and immediately I have all of the queries of any protocol that have included the string Reddit. So I can see that here are the DNS requests, here's my actual DNS, which client, which server, here's the query, here's the actual answer that came back, structured for DNS formatted for type A responses, et cetera, et cetera. And from there, I can get rid of the actual DNS stuff. And this is the real power of what Tyson was talking about with the reassembly thing. Because we're reassembling the full state, it's not just that I can see one protocol, I can see all of the protocols that have involved that and how they're correlated, right? So same time period, different protocol, same data search, the whole bit. I can say, all right, here's the actual requests. Like, what did they request? These users went to certain URIs and made requests. And again, there's a huge amount of data that I can share about all of this if I want to. Here's the actual raw view of everything that's available for each of these HTTP responses. And all of these things are filterable, right? If I just want a thing that came back and said, all right, well, I want a thing that was not compressed. Great, add that as a query. And now I'm only getting things that aren't compressed. Maybe I only want things from this particular client. Great. I can just go through and in the UI, click through, add the filter, drill down, and play in the traffic as I want to. I think all of that stuff is really interesting and powerful. But wait, there's more. The new big bad thing that we've been talking about for about a month now is, I'm really excited about it. I mentioned earlier that we're kind of turning it on its head, where we're going from the idea of a traditional system. It already was powerful, where you can do analysis, and then you're being able to do some exploration from that, and then you're able to hopefully gain insight if you're lucky, and then you're able to actually get data to prove those things out and then take action, right? We're really trying to use machine learning to change that to be insight first, immediate proof and exploration, and then just take action. And the way we're doing that is via this thing called ADDIE. And it's really pretty straightforward. We're able to go through and show you, have there been anything that can constitute anomalous behavior? So you sign up for a service, it starts gathering information about what's happening in your deployment, the entire deployment, everything the ExtraHop sees. It starts saying, all right, well, on a Tuesday at 4 p.m., what's normal for the number of SSH server sessions or the number of database failures or any of those things? And over a couple of weeks, it can build up that data and understand that if it sees a change, it should let you know. So, for example, here I can say, let's look at just SSH, because this makes this easy. I need to deselect all, and then I want to find SSH. Great, so show me just SSH issues that have occurred in the last 24 hours. I can say, well, that's interesting. Several of my SSH servers have had a large deviation, right? Usually we get 0 to 1 per day. We've had really a lot. Somebody's trying to do a thing. And several of these are servers, and here's one client. So let's dig in and see, what's that client doing? I actually want to go look. And with one click, now I'm into, here's the actual client, here's their SSH behavior. They've had many, many sessions, and it's kind of all in one spike. I can get information about which servers they're connecting to. Let's drill down by the list of servers. All right, so I have seen this client is now sending 1,000 and almost exactly 80-something sessions to every SSH server that it has connectivity with. That's pretty indicative of a problem, and that took me what, 2 clicks, maybe 3 clicks? And it's all because I'm able to see this anomaly. I didn't have to configure it. I didn't have to tell it, hey, I should be watching for SSH things. I didn't have to tell it which of my servers were SSH servers. It just sees the traffic, and it starts monitoring those things, and it starts collecting data about what a baseline is, and then pretty soon it's able to tell you if anything has changed. And it's a really important part of the story, because in today's world where the data, the velocity of the data is absolutely untenable to try and keep up with as a human, this is basically, you have effectively an employee that is 24/7, that is always looking at your data, that is able to get information in real time, gain insights, and then send you an email or give you an alert and say, hey, did you know that there's a thing happening that doesn't usually happen? We should look at that. And then you can take the 3 or 4 clicks it takes to take those insights and investigate and get the actual data, and it's a pretty powerful thing. And one last brief note, I realized I was remiss in talking about the one level deeper thing that we can do. So we've talked about transactions, we've talked about high-level metrics. We're doing all of these things that show off the way that we can actually get information out of the system. But there's one further thing that everyone often asks about, which is, all right, great, this is the ExtraHop platform showing things and it talks about transactions, and it's all great. But what if I then need to have proof, whether it's for a legal counsel or for another team, or what if I say, hey, this issue is being caused because there's a misconfiguration, and you need to prove that either to an external vendor or a VAR or to somebody else in your company? Well, with one click, you're able to actually go through, and I now am able to grab the packets associated with the transaction, and I have the PCAP. I would open it in Wireshark, but you don't care about see that. Like, this is now a PCAP that will open in Wireshark or any other tool, and you have the exact data you need without having to run some complex query or wait for hours for that to return or any of those things, because we're already doing the indexing of the flows as they come in real time. We show you the transactions, we give you a UI to investigate, and once you want more information, you just grab it. I'll stop yammering now in the interest of time. I could talk for 3 more hours, but thank you very much for letting me show off a thing that I'm quite excited about.
Thanks, Colin. It was good stuff and a very nice looking interface as well. So we're running a little long, but we're going to take a few minutes just to at least power through some of the questions that came up during the webcast, so if you'll bear with us. So going back to an earlier mention by Tyson regarding TCP reassembly, there was a question on that. So it's a sort of a 2-part question. TCP reassembly, would IP not do that? Appreciate if you can elaborate on TCP reassembly.
Yeah, that's a great question. Colin, please keep me honest.
Sure.
So definitely that's what IP is for. It's reassembling the packets on the client and on the server. But you also want your monitoring appliance to be able to do that as well, because then they can really understand everything that the client and server understands. Otherwise, they're kind of like somebody who's trying to listen in on a conversation from like 15 feet away. So
yeah, there's a big difference between getting a raw data flow and storing that to disk and then being able to run a query against it later, versus getting the actual reassembled information as a flow, as a session. Because you're very right. TCP handles this, and that's the way it's supposed to happen, and it's not really a problem if you are one of the people in the conversation.
Right.
If you're a third party trying to view it as it gets passed back and forth, you're not getting, it's not being interpreted by a TCP stack unless you do the reassembly we're talking about, right?
Yeah.
So you don't have a stack to do the reassembly, so you're getting raw data, and it's really, really hard to do anything that's useful with other than run simple queries.
Yeah, so I mean, if you weren't doing that, yeah, you might be able to get some L7 stuff that's in the header. But if you are doing the TCP State Reassembly in real time, then you can do all the cool things that Colin showed off, where it's not showing only this one transaction, but it's showing all the other L7 stuff that client or that server is doing as well.
Right, and I can pivot between protocols, and I can pivot around everything else that particular IP or whatever is using, et cetera, et cetera. You get context, is really what it gives you.
Yeah, I hope that answered the question. It's a little bit of a, as I said, an esoteric thing, but I'm happy to get in touch with people if they want more information.
Great. And so one last question for you, Tyson or Colin. Very briefly, if we can answer this for our attendee, what additional information do you get versus Splunk? So with your platform versus Splunk?
So very briefly,
Yeah.
I think, so we were looking at this question, Colin and I, and he said, Splunk sees whatever you send it, and that's true. ExtraHop is really looking at all the communications going on in the data center. Of course, we rely on nice partners like Big Mon Fabric to send us all those conversations, but Splunk's not going to do that. With Splunk, you're primarily looking at server logs or application logs or firewall logs, and you only see whatever the dev or whatever the vendor sought to log. If they didn't, include something in the log, then you're not going to see it. Colin, do you have any thoughts?
Well, the easiest, you said it already, the easiest way to explain it as far as I'm concerned from a very high level is, and it's not a knock against Splunk, it's just a technology thing, right? Anything that's dealing with logging sees what you tell it, and something like a platform where you're actually looking at transactions sees what's happening, and those are very different things.
Great. Okay, so one final question before we wrap up. This is regarding Big Monitoring Fabric. So it's, again, kind of a two-part question. Is there a way to program Big Monitoring Fabric, and what interface exists to do that?
Yeah, that's a great question, Angelique. So Big Monitoring Fabric is built with REST first principles, so it exposes REST APIs, and in fact the GUI and the client and the CLIs are REST clients. So the REST APIs are exposed from a single point, which is the Big Mon controller, and it enables the programmability of the fabric. So you can do a lot of interesting use cases like programmable, dynamic programmable actions leveraging those REST APIs. And you can have the tool signal the Big Mon and then program the fabric to do a follow-up action and so on. So.
Okay, thank you. So we are running short on time, so we're going to wrap it up. If we weren't able to get to your question during this webcast, we're going to follow up with you directly to make sure that you get an answer. Again, I want to thank all of our speakers for their time today. Tyson, Colin, Bala, Ted, great stuff. If something here that we discussed today piqued your interest, or you just want to learn more, go ahead and head on over to our website at bigswitch.com, or you can send us an email at info@bigswitch.com. You can also check out ExtraHop at extrahop.com to learn more about their solutions. So we wanted to make you aware of some additional resources on our site. So you can go to our site to download or watch a number of either videos or papers that will be helpful to you. We also have a virtual lab environment where you can experience our SDN Fabric solutions firsthand. You simply go to labs.bigswitch.com to get access. And again, all of our past webinars, including this one, will be posted online at bigswitch.com/webinars. Also, we have an upcoming webinar on Wednesday, May 31st at 10 a.m. The title of the webinar is How to Achieve Scalable Network Visibility and Security with a special guest, security expert Bill Ward. So that's one to check out. It's going to be very interesting. Again, I'd like to thank all of our attendees for their time and participation. We look forward to having you next time. Take care.